given to you. Okay, let's say this is the circle, first circle marked in red, and this is another circle marked in blue, right? Let's say both of these circles are concentric. Concentric means both the circles are having the same center. Let's say it's O, right? It's O. Now into the question, it has been asked that if a line intersects two concentric circles, that means a line is given to you which is intersecting two concentric circles, that means circle 1 and circle 2, right? I mean to say both these circles, that line intersects these two concentric circles at A, B, C, and D, right? That means, let's say if this is a line, let us draw a line first. Okay, if this is a line, right? This is a straight line, right? Then we need to prove, and this line is intersecting these two circles, right? Circle 1 and circle 2 at four different points, right? Definitely four different points. What are those points? Point 1, point 2, point 3, and point 4. And all these 4 points are A, B, C, and D, right? So as per the question, this is the line segment which is intersecting both these circles at four different points. That means you can understand this as a chord which is common to both these circles, right? That means this chord is common, right? Now we need to prove. So what is the data is given into the question? Data is that two concentric. Concentric means circles with same center. So two concentric circles. This is the first data which is given. The second data is given to you is intersecting points are A, B, C, and D are intersecting points. Intersecting points. Now we need to prove what? To prove AB is equal to CD. That means this length AB is equal to this length CD. So this is AB is the intersection of this chord which is lying which is forming due to the presence of these two concentric circles, right? So basically this portion we need to prove. AB, this one, equal to CD, this one, right? So this we need to prove here. I have written it. Do one thing, students. Since the line is intersecting these two concentric circles at four different points A, B, C, and D, and we need to prove AB equal to CD, let us do one thing. From this center, the common center, which is common for both these circles, draw a perpendicular line on this line, right? When you draw the perpendicular line, this will be 90 degree, isn't it? This is a perpendicular. Now the perpendicular, let's say O, which is drawn to the common chord, is, let's say it's falling at M, right? Then we can say that the perpendicular drawn from the center of the circle to the chord, right? And this always bisects the chord if you remember the theorem, right? If OM is the perpendicular, OM is the perpendicular to, let's say, first consider the chord which is the part of a smaller circle or the inner concentric, then it will be BC. If OM perpendicular to BC, then can't we write since the perpendicular drawn from the center to the chord bisects the chord, so that's why we can write BM is equal to CM, isn't it? BM equal to CM, this portion, this is BM and this is CM, right? So this BM is equal to CM. Now similarly, this OM is perpendicular to AD also, right? This OM is perpendicular to AD also. Basically, AD and BC is a common line, is the same line, right? Since OM is perpendicular to AD also, we can write, since OM is perpendicular to AD, so just if you remember how we have proved it, if you want me to show, I am showing it over here for the bigger circle, how these lengths are equal. Okay, if you connect O to A and O to D, right, you can see two triangles are formed here. This is one and another one. So here you can see OA is the radius and OD is the radius, right? This portion. If these two are the radius and this is the common line and this is 90-degree common angle, which is 90 over here also and 90 over into the another triangle also. So you can, by congruency, by proving the congruency of these two triangles, we can prove AM is equal to DM, right? So as we have written for the smaller circle, for the bigger circle, since OM is perpendicular to AD, right, and I've explained you the proof, we can write what? AM is equal to DM, isn't it? AM is this portion, right, and DM is this portion, right? Now here we can see AM equal to DM and BM equal to CM, right? So let us do one thing. From equation number 2 subtract equation number 1, right? Since AM equal to DM, as we have proved after proving the congruency, similarly it happens with the inner circle also, then we can write AM equal to DM and BM equal to CM. So into the next line what we will do, since AM is equal to DM and BM is equal to CM, here I am writing the same again, then subtract the LHS from the RHS, right? When you subtract it, it will be AM minus BM. So AM minus BM is what? You can see AM is this chord of the bigger circle which is bisecting. So this is AM minus BM. Isn't it give you AB here? So let me write it. AM, let me shift it bit up. AM minus BM is equal to dm minus cm. What I did, I just only subtracted the LHS and RHS, right? Then AM minus BM is this section. You can see this is BM and this is AM. So AM minus BM is this section, that is AB. Then we can write AB in place of AM minus BM. We can write AB. And for DM minus CM, DM minus CM, right? So this is DM minus CM will give you this section from C to D. And this is CD, this one, right? Then we can write in place of DM minus CM, it will be CD, right? So in this way, we have proved whatever we have desired, right? So in this way, we have proved AB is equal to CD, right? So what we did, students, let me explain you again. Okay, these are two concentric circles which are having a common center O. From O we drawn a perpendicular OM. You can see OM, right? So this perpendicular, when it's drawn, we prove the congruency of OAM and ODM, right? Because two angles, 190 degree each for both the triangles. This is the common radius, that is OA is the radius and OD is the radius, right? And you can see OM is the common side. Then after proving the congruency, we can say that AM is equal to DM, AM equal to DM. Let me show you here, AM equal to DM, right? That's why we have written OM after drawing OM perpendicular to AD. Similarly, it happens with the inner circle. When OM perpendicular to BC, then BM equal to CM, right? Since BM equal to CM and AM equal to DM, just subtract the LHS and RHS. When you subtract it, you will get AM minus BM. So AM minus BM will leave you this section, which is AB, right? And DM minus CM will leave you the section CD. You can see this one. So in this way we have proved AB equal to CD, isn't it? In this way we have proved AB equal to CD, and hence it is proved, right? I hope you understand the question very clearly. This was a question which came in CBSE in 2012. In 2012 CBSE, this question already came, right? So you can see how this explanation works, and if you understand the question, if the question is tilted or twisted a little, it will not be a difficult question to you, because if you are understanding the concept to solve it, then it's not necessary that previously during the practice you have solved, but when you are having a clear concept, then you can apply those concepts to solve any question which comes in front of you in the question paper during the examination, right? So students, I think this explanation will be helpful to you. If you find it useful, you can just like and subscribe. And yeah, don't hesitate to drop me a message for any query which you have. I will definitely respond to you. You can go through the different selected questions through my playlist into my channel. And yes, it's not like that I'm just trying to help you out or whatever the support I can extend from my end, but the ultimate goal is learning, and I will always say happy learning. Thank you so much for watching, students, and bye bye.